Nothing's faster than the speed of light. Except the speed of darkness. That might sound like the tagline of a grim and gritty movie that's trying way too hard, but it also happens to be true. A shadow racing example. This is a little hard to wrap your head around, but shadows can move faster than the speed of light, even though nothing can move faster than the speed of light. In a second, we'll explain how exactly that's possible without breaking the most fundamental law of physics. But first, this thought experiment might make things clearer. Imagine you have a light that's powerful enough to reach the planet Jupiter. Also imagine that it casts that beam in a cone that's broad enough to cover the entire diameter of the planet. When you pass your finger over the lens, the shadow will cross the entire diameter of the planet, a distance of 86,881 miles, or 139,821 kilometers. The speed of light is 299,338 kilometers per second. So if it takes you less than half a second to move your hand across that distance, then that shadow will have broken the speed of light. Shining a light on the subject. So, remember how we said that nothing can move faster than the speed of light? Well, that's the key. Shadows aren't anything. Shadows are the absence of something, specifically, photons, or particles of light. Since there's nothing that's actually traveling the distance, the only thing that's moving is an area where photons are not. There's no information that's being transmitted faster than light, only a blockage of information. That means, your interplanetary shadow puppet show doesn't break any physical laws, only the hearts of your interplanetary audience. Darkness doesn't necessarily mean the absence of information, rather, darkness means the absence of light to some extent, but there are many more types of information, such as sound, touch, taste and odor, and all of these can exist in the absence of light. For example, in a dark room, you can hear sounds, feel the shape of objects, and smell, all of which contains information. In addition, there are many other things in the universe that cannot be seen with visible light. Such as radio waves, X-rays and infrared radiation, all of which contains essential information about the world around us. So, it is true that darkness may, in some ways, limit our ability to process information, but this does not mean without light there is no information. So why couldn't darkness win in comparison to light in our first example? In order for two things to race, they must both be present at the same time. Otherwise the outcome of the race would only be a speculation. Make sense? Raw light will always cancel out darkness, or shadows. Now if you are in some kind of a dome, or have some kind of bioengineered light, that doesn't fade away darkness, while still emit some kind of light that our spectrum of light can see, then yes, it is quite likely that light and darkness can coexist at the same time. Now theoretically in a parallel universe there is a timeline where light naturally coexists with darkness. Unfortunately that's just a speculation, but I can for sure say, that in our universe, as far as we know, with the knowledge we have gained so far that the answer is a resounding no. Darkness and light can't coexist, at least not in this timeline. But, there are an infinite number of timelines out there, so anything is possible when it comes to space-time, and the mysteries of the universe.